Hey everyone, welcome to this video. Today, let's talk about load resistor. What does it mean? Why do you need it? Do you even need it? Where do you connect it? Where do you mount it? What's the value of the resistor? What is its purpose? What's the material it should be made out of? What is it doing actually? All of those and more questions I'm going to answer in this video. And this will be sort of a webinar or a sort of a class type of video, so I'm not going to be cutting the video or anything like that. I'm going to go over everything slowly, so let's do this. So here's what's happening. I have this ATX power supply unit. I want to turn this ATX power supply into a lab bench power supply unit. Now, that's a really fun project. Now, in order to do that, I need to stabilize this ATX power supply unit. I need to make sure that voltage output lines, which I'm just going to call power rails in this video, I need to make sure that power rails are stable. So here we have, take a look at this sticker. Let me see if I can get a better image of this sticker maybe. Let's see if we have it anywhere. Maybe like there. So if you take a look at this sticker, you probably have this sticker on your ATX power supply. It's going to tell you outputs, what type of power rails, like I've said, voltage rails, what power rails you have. 3.3 volts, 5 volts, 12 volts, minus 12 volts, and plus 5 volts standby. Those are power rails that I have on this ATX power supply unit. I need to make sure that those are stable. Why? Because that's how these voltage lines, these power rails are supposed to be. They are supposed to be stable. If it's supposed to output 5 volts, that's what I should be getting at the output. Now, take a look at this. I don't have to get exactly 5 volts. There is a tolerance range, usually 5 to 10%, something like that. So there is a tolerance range of plus and minus percentage that it can be off. So it doesn't have to be exactly 5 volts. It can be 4.8 volts. It can be 5.3 volts, for example. That is still considered 5 volts. And that's still fine. So for example, also it can be 11.8 volts. It can be 12.4 volts. That's still considered 12 volts. It can be 3.3 volts. It can be 3.4 volts. 3.2. That is still considered 3.3 volts. Because you're never going to get exact numbers with electronics, with electricity in general. Never exact. So we still round them up. It's still fine to consider it. For example, on a 5 voltage power rail, it's still considered 5 volts, even if it says, for example, 4.8 or something like that. So you get that. So, but what's important is that those voltages are stable. If it says 5.2 volts, it should constantly stay on 5.2 volts. Let me show you how the testing looks like. I simply power on the ATX power supply and I test the voltage rails. Look at this. This is a 3.3 voltage rail. I'm getting 3.42, but look how it's stable. It's constantly sitting at 3.42. It's not jumping up and down. It's not 3.43, 41, 50, 3.3, 3.30, 3.35. It's not jumping up and down at all. This last number isn't changing at all, as you can see. That's a good thing. That's how you want your ATX power supply to run, because it's outputting direct current. Direct current is supposed to be as stable as possible, something like this, like what you can see on this digital multimeter. So this already gives you an idea how to test an ATX power supply. Turn it on by itself and then just test the voltage rails, the power rails that is, test them out and see what voltage they are outputting, and are those voltages stable. That will tell you if your ATX power supply even needs a load resistor. We'll get to what load resistor is, what material, and all of these things, but let's first talk about, do you even need it? Some ATX power supply units, the newer types usually, the newer it is, the better, I suppose, usually they already have a built-in load resistor. ATX power supply is going to run unstable. It's going to be jumping up and down. It's going to overheat. It's going to damage itself if there is no load to control it. Just imagine a horse running around without rider. Horse can run how much it wants. It can jump over a cliff. It can do whatever it wants. It can break its neck, break its legs, tire itself, sleep when it wants. It can do whatever it wants. But if there is so basically a horse like that is unstable. Now, if there is a rider on the horse's back, aka the load, this rider is going to give direction to the horse. It's going to stabilize it. It's going to make it run faster when it wants to. It's going to give it direction. So a load, in this case, stabilizes our ATX power supply. Your ATX power supply in your computer is connected to motherboard, to graphics card, to a processor, to sound card, to hard drive, solid state drive, to optical DVD drive, CD drive, ROM, whatever you have. All of those things are creating a load on ATX power supply. One thing that's important to remember is that some ATX power supply units require multiple loads, because remember what I just told you. ATX power supply is connected to a motherboard. That is one load. Then there is another, which is graphics card. There is hard drive. That's another load. So all of these loads are connected to multiple voltage lines or to various. You know, for example, I believe graphics card takes 12 volts. Maybe motherboard takes about 5 volts. So you have something that's loading the 12 volts power rail, then you have something that's loading a 5 volts power rail. There's probably something that's loading a 3.3 power rail. So some ATX power supplies need loads on multiple power rails. So usually when you take a load resistor, in this case, you usually put it only to one voltage line or a power rail, sorry. So, but which one? So I wanted to let you know that there is a possibility that you might need multiple load resistors on different voltage lines. So you might need one load resistor on 5 volt, and you might need another on a 12 volt power line. I know I'm saying sometimes voltage rail, power line, power rail, all same things. I'm just talking about the voltages here, different voltages. That's it. So it's just so you know, you cannot know this until you test your ATX power supply unit. It's simply how it is. There is no definitive answer, sadly, because not all power supplies are made equally. Now, here is how it goes. Usually, the sort of a rule of thumb is to take a look at your voltage rails, power rails, whatever. Let's call them just voltage rails. So you take a look at these voltage rails and you see which one gives you the most amps. Where's the biggest number with most amps? The most load, the most current, all the same thing, essentially. So take a look at this. 3.3 volts is giving me 12 amps. But 5 volts is giving me 15 amps. But take a look at this. 12 volts is giving me 18 amps. So it's capable of carrying a load of up to 18 amps. This one has the most possible current, 18 amps. So that's the most possible amperage. So that's the power line, voltage rail, that I want to put the load resistor on. That's how it usually goes. Now, let's talk about what is a load resistor, what is going on there. I already explained what its purpose, but let's find some load resistors and see how do they look like. Then let's find out what should the values of this load resistor be. Now, okay, I figured it out. I take a look at the voltage rail, which one has most amps. In this case, it's a 12 volt line. It has 18 amps. So that's bigger than 13 and 15, obviously. So that's where I want to connect the load resistor to. Okay, now let's figure out the values, the material, all these things, characteristics, whatever we are supposed to know. So we know where to connect it. Do we even need it? Of course, you need to run some tests. Like I've said, you simply turn on the ATX power supply by itself and then test the voltage rails using a multimeter, see what is it outputting. If it's outputting anything that's not stable, then you need an ATX power. Then you need a load resistor. So if the voltages are not stable, I believe you've seen in my video. Let's see if we can find me testing. Look at this. So 5.18. Look, it's not moving at all. It's not moving. Look. So that's how it should be. If it's moving up and down, if this last number specifically is jumping up and down, that means you do not have a stable ATX power supply. If it turns off, also it's not stable. It means it needs some load. As you can see, look, it's not moving throughout the whole time. This thing is not moving an inch, and that's how it should be. So once again, if your ATX power supply turns off, that's also something that's going to tell you that you need some type of load. Now, I'm going to, from now on, refer to this as some type of load. You don't have to use a resistor. You can use something else as a load. You can use optical drive if you prefer, if you want to have optical drive sitting all the time, wiring out or whatever, wires coming out. And if you want to do it like that, you can do it like that. It's really up to you how you want to, or what kind of load you want to use. Some people use light bulbs from cars, from headlights from cars, from automobiles, whatever. Car feels weird to say cars. Anyways, some people use that. There's a 12 volt 55 watt light bulb that's in a headlight of a car, so you can use that as well. Some people use that. Just hook it up to a 12 volt line. We're gonna get to all the calculations, but like I've said, you can use whatever load you want. Only in this case, it's really practical to use a resistor as a load because it fits inside the case and you're really good to go. It's a small, it creates nice amount of load, so you're good. Okay, let's take a look at some load resistors. If you type in a load resistor, this is what you are going to see. So it looks metal like this. Let's see if there is anything else that can be used as a load resistor. Aha, look at that. Here is another one. So these are usually the resistors that you want to use as a load. So this is how they would look like. So, okay, so you might understand, okay, what's the material? This is like ceramic, and I believe, and this is like aluminum. So why these two? Why not anything else? Well, first and foremost, you're going to notice that these resistors are bigger than usual resistors. The bigger they are, it means they can handle more wattage. I'll explain what all of these mean, what the hell does this mean on top of the resistor. I'll explain everything, but first let's take a look at this one as well. So you can see here it has also some inscription. And here's some more. This is basically how they look like. I believe this is a good photo, so we can take a look at this. You want a bigger load resistor, or just bigger resistor, to create a load. Why? Because a resistor is going to heat up. It's going to get warm. The bigger it is, the cooler it will be. I advise you to get this type of resistor, this one that's golden and basic. It doesn't have to be golden color, but it just has to be enclosed in this aluminum casing. And you're also going to notice that it has two holes. These holes can be used for mounting. Because this resistor is going to warm up, you want to mount it to the case of your ATX power supply inside. Actually screw it to the metal of the case, because as it gets warm, it's going to simply dissipate the heat, transfer it to the metal case, and because the metal case obviously is bigger, there's also a fan that's cooling it. All of these things are going to make the resistor even cooler. Yeah, there we go. Cool resistor, what's up? Okay, stupid stuff. Let's keep moving on and not cringe too much. So we understand what material it is. Now let's take a look at what these, what does this text, these inscriptions, these hieroglyphs, what do they mean? You're going to notice that it says 50W6. This is a sort of omega, but I believe this is omega symbol, but in this case it's an ohm symbol. And then we have a J. So 50W means that this resistor is capable of handling 50 watts of power. Hold on. Before we jump into all of this, there is one cool thing that you can find online called Ohm's Law Calculator. So it's a calculator that helps you calculate using Ohm's Law. You don't have to learn what Ohm's Law is. It would be great if you would. It takes like 10 to 20 minutes of watching 2 or 3 videos online to get a good grasp of Ohm's Law. But essentially, it's a calculation that lets you calculate, if you have 2 values, you can calculate the other 2. So you see there are 4 values in total. We have voltage, current, resistance, and power. Voltage is measured in volts, or just unit for voltage is volts. Unit for current is amps. You can see also what the symbol is. Let me see if I can zoom it in better. So the symbol is I, for voltage is V, for resistance it's R, and we measure it in ohms. And then we have power P, we measure it, the unit is watts, W. So if we take a look at the resistors, we see we have 5W. Over here we have 50W. So that means power. How much watts can this resistor handle? Because this resistor is resisting the current, it's going to heat up. So some power is running through it. And it's going to dissipate this power because it's heating up. it's going to dissipate it in a form of heat. So it's transferring this, this resistance and all of this, it's transferring it, this power, it's into heat. So that's what it's doing. The bigger the number, the more heat it can handle. We're going to come to this. How much power do we need? How much power does our resistor need to handle? We're going to get to this. So just so you know, this basically means how hot it gets. Not really, but how much heat can it handle, sort of. That's a better explanation. Then we have 6 ohms and then J. Let's just get it off the way. J means tolerance. So when you test this load resistor using a multimeter, it should show you that it's measuring 6 ohms. Now, J means tolerance of minus to plus 5%. So it doesn't have to be exactly 6 ohms for us to consider this resistor functional. It can be 5.8 ohms. That's still a functional resistor. It's within the tolerance range. I hope you understand what tolerance range means. So that's it. This resistor is supposed to be 6 ohms of resistance. That's basically its value. So we know that this resistor is going to create 6 ohms of resistance, and it can handle to 50 watts. Notice how we have 2 values already that we can input into the Ohm's law calculator. But we don't have to do that. Let's just keep moving on. So next we have 5W. Let's just really quickly take a look at this one. Can you guess what's the power rating of this resistor? 5 watts. So you're going to notice that this one is 50, but this one is 5, which means that this white resistor can handle less power. So we cannot run, if we run 6 watts of power through this resistor, it's going to overheat and burn out. It's going to basically die. Pepperoni, goodbye, rest in peace. So that's it. 20K means 20 kilo ohms of resistance, or 20,000 ohms. You can learn how these units convert all of these, all the scaling of units. So it goes basically, I believe it goes ohms, kilo ohms, mega ohms, and it continues on. So that's basically what it is. So this just tells us 20K just means 20 kilo ohms or 20,000 ohms. Sorry. And then once again we have J, which is 5% tolerance plus and minus. That's all there is to it. So let's take a look at Ohm's law calculator this time, and let's calculate how much power our resistor needs to handle based off of how much resistance it's creating and what voltage line are we going to connect it to. So take a look at this. We are creating a load in a form of current. So how much load do we need to create? Let's first find out how much load do we need to create, because we cannot create any amount of load. We cannot create small amounts of load. That's not enough to stabilize ATX power supply. Imagine a child, not really, or a baby. A baby can't really handle a horse. It can't really control it. So you need to have, somebody who's, I suppose a teenager at very least, to handle a horse, to give it direction. So you see how we cannot create small amounts of load. We still need to create some amount of load. There has to be a minimum. Of course, we can go maximum if we want. You can go as much as you want, but we still need to create the very minimum. So let's find out what is the minimum load we need to create. If I Google, I get the answer. Typical minimum load is 2 to 4% of rated output current. So let's take a look. Over here, I have, let me see if I can find that image really quickly. So over here, I have 12 volts. The maximum is 18 amps. So let's see what is the 2 or 4% of 18. If I type in what is the 4% of 18, I get 0.72. So that tells me I need to create at the very minimum 0.72 amps of load. We can play it safe. I believe that's the best case, what you should do. Let's create 1 amp of load or 2 amps of load. So let's take a look at Ohm's law calculator. Let's first ask ourselves, to what voltage line are we connecting this load resistor? Well, like I've said, we find a voltage line that has the most current possible, which in my case it's 12 volts line. So that's a voltage line I'm going to connect the resistor to. So that's what I'm going to type in, 12 volts. Next, let's type in how much current we want to create, how much load. I'm going to play it safe. I'm going to put in 1 amp. And now let's click calculate, and this calculator will give us the resistor's value and the power it needs to handle at very minimum. Once again, we're not going to play minimums. It's always good to give yourself some headroom, but let's first click calculate and look at this. This tells me that I need to find a resistor that has 12 ohms exactly. In this case, when it comes to resistance, it needs to be exact. It cannot be less or above. It has to be 12 ohms exactly on a 12 volt line if I want to create 1 amp load. So that's basically it. Let's change this number really quickly. Let's say we have 10 ohms resistor. How much load am I going to create? Look at this. Once again, if we have two values, we can figure out the other two. Look at this. Calculate. If I use a 10 ohm resistor, I'm going to create 1.2 amps of current. That's still more than a minimum. Great. We might not be able to find 12 ohms resistor, it's sort of a specific number, but 10 is a round number. We probably will find a 10 ohm resistor. Okay, so let's use this. 12 volts, we are going to create 1.2 amps, and we have a resistor that is 10 ohms. How much power does this resistor need to handle? Well, in this case, it needs to handle 14.4 watts minimum. But we are not going to play minimums, like I've said. Let's give ourselves some headroom. Why do you want to give yourself some headroom? Okay, imagine a weightlifter. This guy, he's lifting weights. The maximum he can lift in one rep is 50 kilos. So 50 kilos. Now imagine what's going to happen to him. How fast is he going to get tired if we give him 50 kilos to lift? He's going to do couple of reps, and he's going to get tired right away. He's just going to do like 2, 3, and he's already going to say, "Oh, my arms hurt. That's I can't. That's how much I can lift. I can't do anymore." And that's it. So, but what would happen if we give this guy who can lift 50 kilos? What if we gave him 10 kilos to lift? He's going to probably be able to work out for 10 days without getting tired, because there is headroom. He can. His maximum is 50, but he's only lifting 10. So let's do that with our resistor. If our resistor needs to handle 14.4, let's use a resistor that's 50 watts. Or 30, something like that. That's the amount I am comfortable with. So maybe 30, 40 watts, 50 watts, 100 watts if you want. It doesn't matter. The sky's the limit. Just make sure it handles the bare minimum. But once again, like I've said, let's give ourselves some headroom. Let's be smart. Because you are going to notice that in electronics, not everything is exact. Notice how when I was telling you there is a tolerance range when it comes to these voltage lines. It doesn't have to be exactly 12 volts. Because there's always some variation. So let's calculate that variation. Let's take it into consideration. And let's just give ourselves some headroom. Why not? It might not be exactly 14.4 watts. It might be 15, whatever. Let's not play minimums. Let's not make our resistor work too hard. Let's not use too weak of a resistor. So I hope you understand that. It's pretty simple analogy. So that's what it is. So you can just use Ohm's law calculator to simply calculate what you want. So in this case, let's say you want to use a 5 volt rail. And we want to create 1 amp of current, because that is more than 4% of 15. So let's take a look at this and see. Calculate. Look at this. I only need a 5 ohms resistor on a 5 voltage line, and it has to handle minimum of 5 watts. In this case, I would use a 25 ohm resistor, and I would be just fine. If I type in online, for example, 5 ohms, 50 watts, I can find plenty of these resistors. Now, these resistors are sometimes called power resistors, because remember, they are supposed to handle a certain amount of power, and they do have a power rating, which is 50 watts. So you're going to see that, and you're going to see something like this, maybe. Basically, you're going to see bigger resistors. Now, you're going to see probably something like this as well, but I really wouldn't use these because you are not able to mount them. Now, I'm not talking about connecting it to a wire. I'm talking about these holes where you're going to screw it in, actually mount it to the case. So, because if you do that, if you actually mount it to the case, as you can see, it has a flat bottom, and it's going to dissipate the heat through the case as well. The fan is going to cool off the case even more, and that's going to make your resistor even cooler, which is a good thing. You don't want to have it running too hot, and trust me, these things can get very hot. You can watch plenty of videos online where people use power resistors and where they overwork them, where they make them too hot. These things really get dangerous. They can burn stuff really easily. They really, really get hot. That's why they are so big. That's why they are enclosed in metal, so they handle more heat. So that's what's going on there. So let's see if I explained everything. We understand, do we even need a load resistor? Because remember, some ATX power supplies don't need a load resistor. Just test out voltage rails of ATX power supply running by itself. I'm not going to repeat all of those things, but let's really recap. So then we figure out, we know the material the resistor should be. We know the values of a resistor. We use the calculator to understand these things. We understand how ATX power supply works. It needs a load to be stable. Then what else we do? We know where we mount the resistor. I believe for the most part, I'm sort of repeating myself. We do these tests, and yeah, I believe I answered everything. Where to connect it, to the values, how much it's supposed to handle, what's going on there, and that's it. I believe for the most part we are good. I think I've explained every single thing. We understand how to figure out which voltage line do we... Now, like I've said, let me just really quickly go over that as well. You might notice that even though you are creating good amount of load on the voltage line that's supposed to handle the most load, in this case for me it's 12 volts, even though you are creating load on this voltage line, you might notice that your ATX power supply is still not stable. This means that you probably need another load resistor on another voltage line. So a different voltage line needs to get some load as well. So you're gonna, if you notice that, just try another resistor. That's the thing. You really need to have a couple of resistors lying around to test them out and see what's gonna happen. Because really you need to run these tests. It's not, nobody can tell you exactly, unless you find a person online that's using the exact same ATX power supply like you are. Then yes, you don't have to run any tests. You can just watch what the other person did. But in this case, I've never seen somebody use this power supply, so I had to test out on my own. And for my case, when I have one more thing I've noticed, once I used the load resistor, my voltage lines were actually more precise. That's one thing as well. So I was in this test, I'm getting 3.42 volts, I believe, something. Let's see if I tested other voltage rails, if I can show you. So look at this, I'm getting 5.25 without a load resistor. But once I used the load resistor, I was getting 5.10 or 5.12, I believe. So I'm way closer to exact, exact rating, which is supposed to be exactly 5 volts. So that's a good thing as well. If your ATX power supply is outputting exact voltages, if there is no deviation, there is no, all this tolerance thingy, if there's no deviation from exactly 5 volts, for example, that means your ATX power supply is really good. And it's calibrated well. It's a good thing, and that's like I said, that's a good thing, right? So look at this over here. I'm getting 12.4. That's 12.41. We just say 12.4. No need to use all these other extra, thingies. So just 12.4, and once I connected the load resistor, I was getting 12.1, I believe, something like that. So it makes it run more stable, more precise as well. So that's as well a good thing. So yeah. So that's about it. I believe I went over everything. I did finish, really quickly, I want to update. I did finish my lab bench power supply. I converted this exact same ATX power supply. I converted it to a lab bench power supply, and it's working fine. Everything's great. I'm getting good voltages. I have a variable point as well, so that's a good thing. You can see over here I have one load resistor which I was testing out to see how it works. You just basically connect it, literally just wire it to the cable like this. Look at this, and you can just then run some tests, and you can actually let it sit there, see if it's going to get hot, then replace it for another resistor and run these tests until you get exactly what you should. You can obviously, like throughout the video, I've mentioned what the general rules of thumb are, and you can play to these rules and hope that everything turns out good, and for the most part it will turn out just fine. You should not worry. But still, if you do have multiple resistors like this, do use them to test out your ATX power supply. So literally what I've done here is I just connected this load resistor to a 5 volt rail. You can see a 5 volt rail is the red color, and then the black color is the ground. So that's just what I've done. I've connected it like that, and I made some tests to see how it's running. I let it run for a while, for 3, 5, 4, something like that, 3 to 5 minutes, to see how hot the resistor gets. Is the ATX power supply going to output stable voltages? Is the resistor going to get too hot? Do I need bigger resistor? All of these things. and you just test it out. See how comfortable you are, how hot does it get. My resistor wasn't getting too hot, so that was a good thing. So, I was comfortable with using it. Plus, there is fan cooling. Like I've said, there is also case dissipating and cooling. So, all of those things into consideration, this resistor is going to run even cooler, so I'm good. So, yeah, that's about it. Let me see if I... Oh, yeah, one more thing. Like I've said, these are called power resistors. And you're going to... where can you actually find these load resistors? Is there some place where these are used with audio equipment? You might have noticed this for those of you who, are into audio engineering, audio equipment and stuff like that. Those audio guys use these resistors. So see if you have any friends like that who maybe can borrow you some resistors just to test it out. You can purchase these later on your own. They are usually fairly cheap, from $1 to $10 depending on the size of the resistor. But yeah, for the most part, that's where you can find these in audio equipment. I'm not exactly sure what audio equipment has these exactly, but you can research on your own. So that's about it. I believe I've told you everything you need to know to be able to stabilize your ATX power supply and use it for your various project. Like I've said, I've used mine to convert it to a variable lab bench power supply. Very useful thing. So that's it. Thanks so much for watching. Hopefully, like I've said, I've given you every information. I've watched numerous videos, read numerous articles, and barely anybody explains what a resistor is doing. They just say you need a load resistor, and then take this type of resistor, and these are the values, use this, and that's it. They leave you with 10 million questions, and that's it. Like really, really small pool of information is available when it comes to these. I guess it's because it's common sense. I'm not sure, because I guess you're supposed to know what resistor is and what does it mean if it's a load resistor and where to connect it and how to calculate it. You're supposed to know all of these things, but it's sometimes you just don't have to know everything. Just need to know what you need to know to complete your project, if you will. So that's it. Hopefully this helps you. It's crazy, man. I can't believe nobody gives you this information as precise as possible. Thanks for your time. Hopefully I wasn't too annoying and my explanations weren't too broad. I really wanted to convey the information correctly. Like I've said, this was going to be sort of a class webinar type of video. No edits, no too much, no cuts and stuff like that. So that's it. Thanks. I will see you in future videos. You can check out, by the way, my website, ytpriest.weebly.com, where I release more information like this, more other useful information. So, pay me a visit sometimes, search around, see if you find anything useful for yourself. What I like to do is I always like to research information. Oh, I'm selling myself. Incredible. But anyways, I always like to research information and find, correct information, complete information at very least. Because like I've said, these people just scraped by. Literally, I watched videos and they just tell you, oh, you need a resistor, load resistor, and just this, and that's it. Okay, but what about 10,000 other questions I have? Yeah, screw that. So, yeah, that's it. Thanks so much. Once again, thanks for your time and attention. Thanks for the support. I will see you in future videos. Bye-bye.